Good morning, everyone. I am Mohammed Salim Raja, a research scholar under the supervision of Dr. Sheikh Mohammed Abu Naim Sher. I have prepared a beamer presentation on my research, on my coursework, on literature review or coursework. My topic is eigenvalue based topological indexes of some graphs. There are some section in there are some section in my topic. I will present my literature review. Now I will present my now I will start my literature review. There are some section. First is introduction, and there is some next introduction. So first I start with the introduction. Graph. Definition of graph. A graph is a pair G equal to VE, where V is a set whose elements are called vertices, sometimes called singular vertex, and E is a set of paired vertices whose elements are called edges. Adjacency matrix. Let GV be a simple undirected graph whose number of coordinate of V equal to n and coordinate of E equal to m. The adjacency matrix of Z is n-cross-n matrix denoted by AG is given by AG equal to Aij n-cross-n equal to 1 if I is adjacent to Z, 0 otherwise. Energy of graph. Let lambda 1, lambda 2, lambda n are the eigenvalues of AZ, then the energy of G is denoted by EG is defined by EG equal to summation over I equal to 1 from I equal 1 to n mod of lambda I. Laplacian matrix. Let d1, d2 to dn are the degrees of 1 to n vertices of G respectively, then the degree matrix of G is denoted by dc is given by d of G equal to diagonal of d1, d2, choose dn. Now we will define the Laplacian matrix of G as Lg equal to dg minus ag, where Lg equal to Lij equal to di if I equal to j equal to minus 1 if I is adjacent to j equal to 0 otherwise. Normalized Laplacian matrix. Let d1, d2, d3 choose dn are the degrees of 1 to n vertices of G respectively, then the normalized Laplacian matrix is defined by Lg Ij equal to 1 if I equal to j, if I not equal to j, and Vi is adjacent to Vj equal to 0 otherwise. Definition of topological indexes. A topological index, also called a molecular descriptor, is a mathematical formula applied to any graph that models some molecular structure. From this index, it is possible to analyze mathematical values and further investigate some physico-chemical properties of a molecule. It is an efficient method to avoiding expensive and time-consuming laboratory experiment. Kirchhoff index. Let GVE be a simple undirected graph whose number of vertices equal to n, the number of edges equal to m. Let 0 less than equal to mu1 less than equal to mu2 less than equal to mu3 choose less than equal to mu n is the eigenvalues of the Laplacian matrix Lg. Then the Kirchhoff index of G is kfg equal to n into summation over 2 equal to summation over I equal to 2 to n on by mu I. Degree Kirchhoff index. Let GV be a simple graph whose number of vertices, coordinate of V equal to n, coordinate of E equal to n. Let 0 equal to lambda 1 less than equal to lambda 2 less than equal to choose to less than equal to lambda n is the eigenvalue of the normalized Laplacian matrix LG, then the degree Coursework index of G is kf star of G equal to 2m into summation over I equal to 2 to n 1 by lambda I. Strata index. Let lambda 1, lambda 2 choose lambda n are the eigenvalues of the adjacency matrix A of G with lambda 1 less than equal to lambda 2 less than equal to choose less than equal to lambda n. The Strata index is denoted by EE, capital EEG of G is defined by EE of G equal to summation over I equal to 1 to n e to the power lambda I. Laplacian Strata index. Let 0 less than equal to 0 less than equal to mu1 less than equal to mu2 less than equal to mu3 choose to less than equal to mu n is the eigenvalues of the Laplacian matrix LG. Then the Laplacian Strata index is denoted by LEEG is defined by LEE of G equal to summation I equal to 1 to n e to the power mu I. Signless Laplacian Strata index. Let the Laplacian matrix L plus of G equal to TG plus AG is called the signless Laplacian matrix of G, and Q1, Q2 choose to Qn are the eigenvalues of the signless Laplacian matrix. Then the signless Laplacian Strata matrix index is denoted by SLEE of G and is defined by SLEE of G equal to summation over 1 to n e to the power Qi. Now there are some Coursework index. Next we have Coursework index of some simple graphs. First, path graph. The Coursework index of path graph of Pn is given kf Coursework index of Pn equal to 1 by 6 into n minus 1 into n into n plus 1. Cycle graph. Coursework index of the cycle graph Cn is equal to 1 by 12 into 1 minus n minus 1 into n plus 1 with n greater equal to 3. Star graph. Coursework index of the star graph Sn is equal to n minus 1 square. Complete graph. Coursework index of the complete graph Kn is equal to n minus 1. Complete bipartite graph. The Coursework index of the complete bipartite graph Pn is 4n minus 3. Now here some Coursework index of some chemically important graph. There are many chemically important graphs, so we have discussed two of these. First of all, Coursework index of the linear hexagonal chain Ln is equal to, given the formula, there is given the formula this is, and then the Coursework index of the linear polynomial linear phenyl of n hexagon and n is minus 1 squares. The Coursework index is equal to 9n cube minus n plus 6n phi n, where phi n is given in the expression, given the below expression. Now the degree Coursework index of some chemically important graph. Let Wn be a pentagonal chain with 2n pentagons. Then the Coursework index degree Coursework index of Wn equal to 7n plus 1 phi n plus 98 n cube plus 84 n square plus 4n by 3, where phi n is given the given expression. Let Bn, the second one is the let Bn denoted the linear polynomial chain with n square, then this. Now some literature review on Strata index. In 2016, Hamid-Reza Bamdad gave us the new lower bound of Strata index. Let G be the graph on n vertices, f edges and T triangles, then cut EE of G, standard index of G, greater or equal to root over n square plus 2mn plus 2nt. Second, in 2019, J.R. Carmona and J. Rodriguez use an increasing sequence converging to the lambda one to obtain an increasing sequence of lower bound of EEG. In addition, they generalize the succession for the standard index of an arbitrary symmetric and non-negative matrices. In 2021, Y. Lee and C. Ye gave us new relation between graph energy and the standard index. Now literature review 1, LEE of G and SLEE of G. In 2019, H.S. Remontel doing this research plan. Our aim is to investigate the Kirchhoff index, normalized Kirchhoff index, standard index, and other eigenvalues based topological indexes for some classes of graphs. These are the first reference from where I took the information given in the above, and this is the second references I took and this is the third references. And now thank you all of you for hearing me and giving me such a nice opportunity to present before you. Thank you, and now thank you for giving me nice opportunity to present myself. Giving an opportunity to present my literature review. Thank you, sir. Thank you, all of you.